Are you ready, kids? 6.5, squares and rhombuses, or sometimes you can say rhombi for the plural for rhombus. All right, let's look at some properties. Let's focus on the square first. Here is some properties of the square. It has the 6 properties of a parallelogram, so all of the properties that are for a parallelogram, the square also has. On top of that, the square has one more property, and the property is that it has 4 equal sides and 4 right angles. Now that sounds like there's 2 properties in there, but it's actually just one property. And it's one because they both have to happen. 4 equal sides and 4 right angles. All right, so there's a picture of a square. You guys all know what a square looks like, but all angles have to be 90 degrees, and then all the sides have to be the same in order for it to be a square. All right, a rhombus also has all 6 properties of a parallelogram, but it has a few more properties on its own. It has congruent side theorem, which says a parallelogram is a rhombus if and only if all of the sides are congruent, so all of the sides are the same. Notice that sounds like the square, but the angles don't have to be 90 degrees, and so that's the difference. Is a square has to have 90 degrees, a rhombus does not. All right. It also has the perpendicular diagonals theorem, which says a parallelogram is a rhombus if and only if its diagonals are perpendicular. All right, so the diagonal to go from here to here and to go from here to here, if I were to draw that line a little bit straighter, the theorem says that the angle inside must be 90 degrees. All right. The angle bisector theorem theorem says a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So diagonals again. Diagonals here. It turns out that the theorem says that those diagonals actually cut the angles in half. So this angle is equal to this angle is equal to this angle is equal to this angle. And this angle is equal to this angle is equal to this angle is equal to this angle. All right, and that happens with a rhombus. Okay, let's go ahead and do some examples. Here are the 4 quadrilaterals that we've learned so far: a parallelogram, a rectangle, a square, and a rhombus. We'll throw you some questions. Which quadrilaterals, there could be more than one, has 4 right angles? All 4 right angles. A rectangle and a square. Which quadrilaterals has 4 congruent sides? All 4 sides congruent. A rhombus and a square. Which quadrilateral has 2 pairs of parallel sides? So it has to have 2 pairs of parallel sides. All of them have 2 pairs of parallel sides. And here's a hint. If the theorem, or if the question is true for a parallelogram, then it's going to be true for all of them, just because all of them have the same properties as a parallelogram. How about which quadrilateral has diagonals that bisect each other? So diagonals that bisect each other. Now that one's tough because there's a whole bunch of diagonals theorems in there. But it turns out that all of them have diagonals that bisect each other. All right, let's solve some of them. This is given a square. All right, so when I give you a square, that means you have all these properties of a square hopefully listed, and you can just check. All right, so if this is a square, that corner must be 90 degrees. So 10x equals 90 degrees. Pretty easy. X equals 9. All right, let's do a rhombus. Given W, X, Y, Z is a rhombus, and they give you some information. I just labeled the picture. If you have to draw your own picture, you have to be really careful the way you draw it. You actually have to follow the order that they give you in the letters. W you can put wherever, but then the next one has to be X, and then Y, and then Z. It has to go in the order that you would draw it. You can't go W, X, Y, Z, because it would go W, X, Y, Z, and then that wouldn't make a parallelogram or would not make a rhombus. So if you were asked to draw something, you just have to draw it consistently. All right, and then everything is labeled nicely. We have to solve for Y, which is right here. But it turns out that these guys have all the given information. So if you think of all the properties in a rhombus, well, what do we know about the X and the Z? We do know that they are equal to each other. Opposite angles in a rhombus are equal to each other. So we set them equal to each other, use a little bit of algebra, solve for X. You should get X equals 5. Once we get X equals 5, you can plug it back in to here, or the other one, whatever you want. And then we should know another property is that these two together are supplementary, so they should add up to 180. So I will substitute in the X for 5, simplify, solve for Y, and we should get Y equals 60. All right, so that's a little bit of work, but not too difficult. Well, here's another example. If I give you RAMB is a rhombus, then all of those properties of a rhombus are now true, and let's use them to find BO. So BO is right here. That one's easy. It should be equal to 11 because of the diagonals property. The diagonals are bisected, they're cut in half. RO is right here. That one's a little bit more difficult, but if we look at this diagonal and we look at this side that says 13, we kind of have this triangle where this is 13, this is what we're looking for, and this is 11. And if you remember, the property for a rhombus is inside the diagonal, we have this 90 degrees. And so from there, maybe you remember how to solve the side of a right triangle. If you remember that theorem, it is called the Pythagorean theorem. When you do the Pythagorean theorem, a squared plus b squared is equal to c squared. You should get radical 48. And if you simplify radical 48, you get 4 radical 3. All right, let me erase some of this stuff. Next up, MO. MO is just on the other side, and it should be the same as RO. So same thing. How about RB? RB is this side. Remember, it's a rhombus, so all the sides are the same. And so RB must be 13. How about the angle? Angle BAM. which is this angle right here, BAM. And again, if you remember the theorem, it is the angles are cut in half, so BAM is 20 degrees. All right, so that's a lot of information because there's a lot of properties, which is fine. You just have to know them all, list them all out on your notes, and you should be good to go. Oh, angle RBA. RBA, this one over here. Same thing, 20 degrees. All right, let's move on to the last slide of the day. A proof. All right, so let's go ahead and do a proof. It is given that QUIZ is a parallelogram. So this whole thing is a parallelogram, which means it has 6 properties of a parallelogram. And we're going to use some of those properties to prove that it is also a rhombus. All right, and in order to show something's a rhombus, you just have to show one of the properties that was specific to just the rhombus. In this case, I'm going to try to show that all the sides are equal. All right, so if I can show all those sides are equal, then I have a rhombus. So let's start the proof. QUIZ is a parallelogram, and QUZ is isosceles. That is given. Well, QUZ is isosceles. Let's use that. If QUZ is isosceles, then that means QZ is equal to QU. That's just what isosceles means. 2 sides are the same. Definition of isosceles. Let's see, what else do we have? QZ is equal to UI. All right, so QZ is equal to UI. How do we know that those 2 sides are the same? Well, if it's a parallelogram, then opposite sides are always equal. Opposite sides theorem. How about QU and ZI? They're equal to, because again, opposite sides theorem in a parallelogram. All right, and if you look at the picture, I think that is enough information to show that QUIZ is a rhombus because all the sides are equal. All right, so that is all we have. Go ahead and try the homework.